All right, so here's my second exercise. Find the equation of the line that is tangent to the curve y equals sine x plus pi over 2 at the point on the curve where x is equal to negative pi over 4. So I'm still finding an equation. Does not matter what the shape of my original function is. If I'm finding the equation of a tangent line, it is a line. So I'm still going to be using y equals mx plus b. I'm going to use a derivative to find my b. And I have a point to find everything else I need. So let's start by taking the derivative of this equation. So y prime is equal to, okay, so when I do this, I'm going to take the derivative of the sine, which is going to be cos, and then I leave the insides as is, but then I times that by the derivative of what's on the inside, which is 1 for the x. The derivative of x is 1. Derivative of pi over 2 is 0. So it's just going to be times 1. So my derivative in this case was nice and easy. My y prime is equal to cos of x plus pi over 2. So a couple of things I'm going to need to figure out. First is let's just find the slope. So remember that y prime is the slope. So I want to find the slope at the point where x is negative pi over 4. What I'm really saying is I want to find y prime at negative pi over 4. So that's the cos of negative pi over 4 plus pi over 2, which is the cos of, pi over 2 minus pi over 4 is pi over 4. Awesome. Now, I don't want to use a calculator for this. I don't want to come up with some kind of crazy answer. What I want to do is remember my special triangles. So if I kind of draw down my special triangle again, and when I have the pi over 4, I'm going to have my 1, 1, root 2, where that angle is pi over 4, and so is the other angle. So because it's the 45-degree triangle, I know that the cos of pi over 4 is equal to 1 over root 2, and that was by using my special triangle. So I'm just going to erase that special triangle because I want to use that space. But now what I need to do, and I'll choose a different color for this, is I need to find y at negative pi over 4. Because I need my y value to find the equation of my line. So my y is sine of pi over 4, because that's what my x was. So remember, I'm plugging pi over 4 plus pi over 2. And it just nicely works out to the same using that same special triangle, that the cos of pi over 4 and the sine of pi over 4, oops, if I wrote that down right, are going to be the same thing. So the last step I have is just to find my equation. So I'm going to use my y equals mx plus b. And I have my y. I have my m. And I have my x. So 1 over root 2 equals 1 over root 2 times negative pi over 4 plus b. So it's not going to be a great b, but we can just kind of figure this out here. So I'm going to have 1 over root 2 equals negative pi over 4 root 2. And then when I move that over, I'm going to have that my b is equal to 1 over root 2 plus pi over 4 root 2. And I could kind of make that into one nicer fraction before I write my equation down. So with common denominator, it's going to be 4 root 2. And it's going to be 4 plus pi over 4 root 2. So final equation. So I got to get my slope again. My slope is 1 over root 2. And there we go. So not a super fun and easy looking equation, but it's still the same process. It still works. Okay, so there are my examples of using sine and cos. Hope that is helpful.